Assalamu alaikum and welcome everyone to the second part of our molecular biology ASCP preparation series, Molecular Techniques. I'm Dr. Lai Abdelati and I'm really excited to share my knowledge and experiences with all of you through this series. So let's dive in together. Our focus for this season will be on PCR reaction optimization, a cornerstone of molecular diagnostic and high yield topics for molecular biology ASCP preparation exam. So let's dive and welcome to the season. Today we'll explore the multiple choice question covering part B, reaction optimization. This section will focus on the fundamental concept related to the primer length, multi-temperature, GC content, and specificity influence PCR efficiency and accuracy. So now let's move to the question part and see the first question we have today. So the first question we have, how does a low concentration of buffer affect the annealing step in PCR? Insufficient buffer concentration can lead to inadequate ionic conditions, preventing proper primer template binding and reducing the efficiency of annealing step. So the correct answer here is prevent primer template binding. All right, let's move on. Okay, next question here. What is the function of a buffer in a PCR reaction? The correct answer is to provide optimal conditions for DNA polymerase. What is the role of magnesium chloride in the PCR reaction? Magnesium chloride, as we know, is the crucial for the activity of DNA polymerase, which is necessary for the synthesis of new DNA strand during PCR reaction. All right. So the correct answer here is serve as the cofactor for DNA polymerase. All right. What is the primary function of DNTBs in a PCR reaction? The correct answer is to provide the building blocks for new DNA strands. All right. Let's move on. What is the correct order to set up a PCR reaction? All right. First, add the master mix to every tube. This provides the essential component need for the reaction. All right. Next, add the patient sample to the tube designed for testing. In separate tube, add the positive control, which contain a known DNA sequence to confirm the reaction is worked correctly. Finally, set up the negative control by adding only water or another non-template control instead of DNA. This help check for contamination. All right. So each tube gets the master mix, but the patient sample, positive control, and negative control are added separately to their designated tube. All right. Let's move on. All right. Next question here. What is the purpose of performing a gradient PCR? The correct answer to find the optimal annealing temperature. Actually, gradient PCR helps determine the optimal annealing temperature by testing a range of temperatures in a single experiment. All right. Okay, next question. Increasing the annealing temperature in a PCR primarily helps to. The correct answer is reduce non-specific binding. Actually, higher annealing temperatures reduce non-specific binding by ensuring that primer bind more specifically to the target sequence. All right? All right, the next question. How can you improve the yield of PCR products? The correct answer is increase the number of cycles. Actually, increasing the number of PCR cycles can improve the yield of amplified product by allowing more rounds of DNA synthesis. All right, let's move on. Okay, next question. Formamide is added to the PCR reactions too. The correct answer, reduce the melting temperature of DNA. Actual formamide lowers the melting temperature of DNA, which can help in amplifying difficult template with the high GC content. All right, let's move on. Next question. How can you minimize the non-specific amplification in PCR? The correct answer, increase the annealing temperature. Increasing the annealing temperature can help reduce the specific binding of primer to non-target sequences, all right, thereby minimizing the specific amplification. All right. Okay, next question. What is the purpose of using hot start DNA polymerase in PCR? The correct answer is to prevent non-specific amplification. But how? Actually, hot start DNA polymerases activated by what? Activated by heat, which prevent non-specific amplification during the initial step of PCR reaction. All right? Okay, the next question. What is the effect of increasing the annealing temperature in PCR? The correct answer is reduce non-specific binding. All right? Increasing the annealing temperature can help reduce non-specific binding of primer to non-target sequences, thereby increasing the specificity of PCR reaction. Let's move on. All right, next question here. What is the potential cause of intense small bands in a gel that are not the target of amplification? All right, the correct answer is 3' homology of primers causing primer dimers. All right, let's move on. If you found this content helpful, please don't forget to like, share, and subscribe to our channel. Your supports mean the world to me and help me create more valuable content for you. Thank you for being part of this journey. Let's continue. Next question. Which of the following is the common method to revise the specificity of PCR products? The correct answer is gel electrophoresis. As we know, gel electrophoresis is commonly used to separate and visualize PCR products, allowing verification of their size and specificity. All right, let's move on. Okay, the next question here. Reducing the extension time in PCR can help to. Or the correct answer is increase the specificity of the reaction. Actually, shorter extension times can help reduce non-specific amplification, thereby increasing the specificity of PCR reaction. All right? Okay, next question. Why it is important to use a high quality intact DNA as the template in PCR? The correct answer is to avoid degradation and ensure accurate amplification. Okay? All right, next question. Which of the following is the potential problem when using long primers in PCR? All right, longer primers are more likely to form secondary structures, such as the hairpins, right? Which can interfere with the primary binding and reduce the efficiency of PCR reactions. Okay, let's move on. Okay, the next question here. What is the potential consequence of using too high concentration of tag DNA polymerase in PCR? All right, the correct answer is non-specific amplification. Actually, using of high concentration of tag DNA polymerase can lead to non-specific amplification by increasing the likelihood of the enzyme binding to and extending non-target sequences. All right, let's move on. Okay, next question. How does excessive amount of tag DNA polymerase affect the PCR reaction? The correct answer is to increase the formation of primer dimers. Actually, using too much tag DNA polymerase can increase the formation of primer dimers, which are non-specific products that compete with the target DNA for amplification. All right, let's move on. Okay, the next question here. What is the impact of high tag DNA polymerase concentration on the overall PCR efficiency? The correct answer, it reduces the efficiency. All right. As I said, excessive tag DNA polymerase can reduce the overall efficiency of PCR by promoting non-specific amplification and primer dimer formation. All right. All right. Next question here. What is the potential consequence of using too low concentration of tag DNA polymerases in PCR? All right, the correct answer is reduced amplification efficiency. Okay, actually, insufficient tag DNA polymerases can lead to incomplete or inefficient amplification of the target DNA, resulting in lower yields. All right. Okay, next question here. How does a low concentration of tag DNA polymerase affecting the elongation step in PCR? All right, the correct answer, it decreases the elongation rate. Actually, low level of tag DNA polymerase can slow down the elongation step, as there may not be enough enzymes molecule to efficiently synthesize new DNA strands. All right, let's move on. Okay, the next question here. What is the impact of low tag DNA polymerase concentration on a overall PCR reaction? All right, the correct answer is it inhibits the PCR reactions. Actually, too little tag DNA polymerase can inhibit the PCR reaction by failing to amplify the target DNA efficiently, okay, leading to poor or no amplification. Okay, next question. What is the potential consequence of using excessive high concentration of buffer in a PCR reaction? All right, the correct answer is decreased enzyme activity. Actually, high buffer concentration can lead to suboptimal pH levels, which can negatively affect the activity of DNA polymerase enzymes, reducing its efficiency. Okay, next question. How does a high concentration of buffer affect the denature step in PCR? The correct answer is it increases the melting temperature. Actually, excessive buffer concentration can stabilize the DNA double helix, requiring higher temperature to denature the DNA strands. All right? All right, next question. What is the impact of high buffer concentration on the overall PCR reaction? All right, the correct answer, it inhibits the PCR reaction. Actually, too much buffer can lead to ionic imbalance and suboptimal pH, which can inhibit the PCR reaction by affecting enzyme activity and DNA stability. All right? Okay, the next question. What is the potential consequence of using too low concentration of buffer in a PCR reaction? The correct answer is reduced yield. Actually, low buffer concentration can result in insufficient ionic strength and suboptimal pH, right? Leading to reduced enzyme activity and lower DNA yields. Let's move on. Okay, next question. What is the impact of low buffer concentration on the overall PCR reaction? The correct answer, it inhibits the PCR reaction. Okay, let's move on. Okay, the next question here. What is the potential consequence of having too high concentration of DNTBs in a PCR reaction? The correct answer is decreased fidelity of DNA polymerase. Actually, high concentration of DNTBs can lead to decrease the fidelity of DNA polymerase, meaning the enzyme is more likely to incorporate incorrect nucleotide during DNA synthesis. This can result in a higher rate of mutation in the amplification DNA. Okay, the next question here. Which of the following is the common issue caused by excessive DNTB's concentration in a PCR reaction? The correct answer is enhanced formation of primer dimers. Actually, excessive DNTB's concentration can lead to formation of primer dimers, which are non-specific products formed when primer anneal to each other instead of target DNA. Okay? All right, that's all for today. I hope you enjoyed this lecture. Please don't forget to like, comment if you have any questions, share and subscribe to our channel to receive all the latest lecture. I also encourage everyone taking the test to share your question with us so that everyone can benefit. Salam.